Every day since November 1998, the International Space Station has been orbiting the Earth at a speed of 28,000 kilometers per hour. Having spent several months on board the International Space Station, the time has come for 3 of its crew members to travel back to Earth. The return journey aboard a Soyuz capsule takes 3.5 hours. Before it can start, there's a lot of preparation to do, both in space and on the ground. The normal landing site for the Soyuz is Kazakhstan. A group of ground-based experts prepare meticulously for this operation. They take into account the current orbit of the station and then select the most appropriate landing site on the ground. The landing site is checked by the search and rescue team to make sure that the terrain is flat and free from any obstructions that could complicate the landing. The search and rescue team is able to operate even in extreme weather conditions. When all the information has been analyzed, the optimal return trajectory is calculated. One week before the Soyuz undocks from the station, the instructors and controllers located in the Mission Control Center near Moscow conduct a remote training session with the crew and the onboard simulator. During this session, the crew are reminded about the most important actions they will have to perform during the re-entry. They carefully run through the procedures for each critical step, including the scenarios that could lead to an emergency descent. They are also briefed on the latest details of their trip back, such as landing conditions and the precise timelines for the activation of vehicle systems. The onboard crew runs a test of the Soyuz vehicle and begins packing items that will travel with them back to the ground. The Soyuz is then activated, and the crew starts preparing it for undocking. When instructed by the ground controllers, the crew say their goodbyes to the colleagues staying behind and close the hatch that separates the Soyuz orbital module from the station. The hatch is carefully checked to make sure there are no leaks that could cause an unexpected cabin depressurization. The crew members put on their spacesuits and enter the descent module that they will occupy for the ultimate roller coaster ride back to Earth. Former astronaut Frank de Winne is now head of the European Astronaut Center in Cologne. He remembers clearly the emotions he felt as he was about to leave the International Space Station.
Wow, today I'm really going home. Because of course, the days before you're preparing for the descent, you're reviewing all the procedures, you're going through all the radiograms, but it's only at the moment that you're in your spacesuit and that the hatches are closing that you know that 4 hours later you will be back on Earth.
Both crew and vehicle are now ready for the undocking sequence. The Russian segments of the station have several docking ports for hosting Soyuz vehicles. In this example, the vehicle is going to undock from the so-called service module. In this case, the undocked Soyuz reaches an orbit below the station. The orbital velocity of the Soyuz also increases. Sometimes, however, the Soyuz is docked to a port underneath the station. In these situations, approximately 40 minutes before the undocking, the station changes its orientation. The Soyuz then undocks and joins a higher orbit, and its velocity decreases. In both cases, after one revolution of the Earth, the orbits intersect, but because of their now different velocities, the station and the Soyuz arrive at the intersection point at different times. This prevents any possibility of a collision between the two vehicles. When the flight director is ready, a "go" is given to the crew to initiate the undocking. The crew commander issues the command to open the Soyuz hooks. These are the only mechanical devices holding the vehicles together. After approximately 3 to 4 minutes, the hooks are fully opened and the Soyuz is no longer firmly attached to the station. A set of pushers that were kept mechanically compressed while docked gently ease the Soyuz away from the station at a relative speed of 12 to 15 centimeters per second.
Undocking confirmed at 9:56 p.m. Central Time.
Being so close to the station, the Soyuz propulsion system is inhibited in order to avoid contamination of the station with residual chemical dust produced by the Soyuz thrusters. The crew gets visual confirmation of the separation through the image provided by the external TV camera and also from indications displayed on their monitors. ESA astronaut Paolo Nespoli returned to Earth aboard a Soyuz spacecraft at the end of Expedition 27.
I didn't actually felt the detach when we detached from the station. Physically, I did not feel it. The physical departure of the station is done because of a push or some spring that there is inside. You don't want to start your engines close to station because you're going to plume everything. So you're just kind of drifting away, and what you're doing there, what we were doing, we're just looking at the instruments, looking at the camera outside and checking that the Soyuz would be inside the departure corridor. This is what we were doing. Didn't really felt anything. The only thing is that we felt we started this long journey back to Earth.
3 minutes later, when the spacecraft has moved about 20 meters, the crew monitors the 15-second burn that increases the separation speed up to 2 kilometers per hour. This leads the Soyuz to a safe position relative to the space station. After the undocking, the ground controllers upload the data needed by the onboard computer to autonomously perform the descent. The crew is in constant communication with the ground. They verify the validity of the data before allowing the computer to use it. At this stage, the crew must pay special attention to prepare for the next critical operation, the deorbit burn. As can be seen, although the Soyuz is now far away from the station, it is still orbiting the Earth at an altitude close to that of the ISS. The purpose of the deorbit burn is to force the Soyuz to decrease its speed. As a result, the trajectory of the vehicle changes and it re-enters the atmosphere. The atmosphere acts as a natural brake and does most of the work in slowing the Soyuz down until a set of parachutes opens and ensures a relatively soft landing. This braking is achieved by using the main engine located in the rear side of the spacecraft to push against the direction of travel. The required orientation and duration of the braking impulse must be precisely calculated and achieved because it directly influences the steepness of the re-entry path.
If we don't burn enough, then we have still too much speed and we will still be too high in the atmosphere, and we can actually skip off the atmosphere and then go further into space. And that, of course, would not be a successful re-entry. On the other hand, if we burn too much and we come in too steep, then we will have too much speed when we are in the lower parts of the atmosphere. The heat that is normally around 2000 degrees Celsius will be much higher and we have a risk of burning up. So also therefore it's very critical that we do the correct deorbit burn and that we really fix this around 120 meters per second.
To achieve the correct burn, the main engine fires for exactly 4 minutes and 45 seconds. The Soyuz now follows a trajectory that will lead it to intercept the dense layers of the atmosphere, leading to a safe re-entry and landing about 55 minutes later. As the vehicle travels along its trajectory, about 30 minutes before landing, and at an altitude of roughly 140 kilometers, it separates into 3 parts: the orbital module, the descent module, and the instrument compartment. There is no chance of the individual modules colliding with each other. This is called impactless separation. Only the descent module hosting the crew will make it back safely to Earth. The other 2 will disintegrate and burn up in the atmosphere.
The separation of the spacecraft in the 3 parts is happening through several seconds because there are several parts that gets detached after one or the other. All of these actions are done with explosive bolts or explosive implements. seen from inside of the spacecraft, it felt like there was somebody outside the spacecraft with a sledgehammer that was hammering here and there, up and down. And so every few milliseconds, the spacecraft was shaking with this bang, 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 bang. It felt really interesting, actually.
The descent module experiences extreme high temperatures during re-entry, so to protect it and the crew inside, it's fitted with a special protective coating and has a heat shield on its base. As the atmosphere becomes more dense, the descent module positions itself so that its heat shield points forward. The capsule is about to enter the Earth's atmosphere. This will be the most stressful part of its journey home.
By the time we were supposed to re-enter the atmosphere, I actually looked out from our window and I actually looked, we were tumbling. And I was a little bit puzzled because I thought we need to re-enter in a special angle. So I started looking at procedure, we did a few things, and when I looked out again, I saw that we were already inside this plasma things. It was getting really red, and actually the window was getting pretty dark. What was happening that a plasma stream is actually burning the outside layer of the window, which has a protective cover. So it was kind of interesting. At that point, I really did not feel that much. I mean, the gravity starts grabbing you, but it's very gentle at the beginning, and you actually use it to feel or go into the seat and buckle up, pull your straps so that you really lay into the seat. It was an interesting feeling.
The descent module follows a path that is similar in shape to that made by a surfer riding a big wave. Like a surfer, the Soyuz is able to make small adjustments to keep itself on track. So how is the trajectory of a free-falling capsule controlled? Even though it doesn't have wings, the Soyuz capsule is able to change the way it flies through the air. The design of the Soyuz enables it to do this. The capsule's lift increases when it rotates in one direction and decreases if it rotates in the opposite direction. In this way, the capsule is able to keep to its planned trajectory. As a side effect, this rotation also induces a sideways displacement of the module. This effect is very useful because it gives more flexibility for the selection of the landing site. This sideways maneuver has already been taken into account when selecting the optimum trajectory. During the descent in the atmosphere, the crew feels the effect of the deceleration when their weight exceeds several times their own weight on the ground. The maximum G-load, 4G, is experienced when the capsule reaches an altitude of roughly 35 kilometers, when it's already been traveling for 6 to 7 minutes in the atmosphere.
Gravity is a very, very strong force. We do not understand here on Earth how gravity has such a hold on our body, on what is around us. You do feel it when you come back from space, because now you have been in a non-gravity environment for a long time, and then you see all these forces grabbing you. You look at stuff and you feel your hands are heavy, you feel your watch weighs a ton, your books, the materials around you, your head, it's extremely heavy. And it's really, really, really a very strong feeling.
In the unlikely event that the automatic control system fails, the crew is able to use a manual hand controller as a backup. They train extensively to prepare for this possibility. Another option is the ballistic descent. The spacecraft starts spinning and flies a much steeper trajectory without any additional sideways displacement. The G-load in this case will increase up to 9. When the capsule reaches an altitude of 10.5 kilometers, its speed has already decreased from 28,000 to 800 kilometers an hour. In order to further decrease the speed, the parachute cover is jettisoned and a series of parachutes are deployed.
At the end of the atmospheric re-entry, you really start hearing the noise of the wind and the sound. You're almost breaking the sound barrier. Then in the opposite direction, of course, you're coming back into the normal area of flying. And this is around 30,000 feet that the parachute has to open. This is actually a very critical moment, and it's one of the only things in the Soyuz where the crew does not have a manual override. So this is only an automated system. So far it has always worked, and we also have a backup parachute that can help us in case that the main would not open. But it's also a very violent moment. You can imagine this 2,000 kilogram capsule that is soaring at the speed of sound through the atmosphere, and then all of a sudden you have a parachute that opens on the side and that pulls on you like with a little string. It's almost like a yo-yo, and you see the capsule going all around. It's much worse than in a roller coaster because it motions in all directions, and it's a little bit scary for some of us. For some others it can also be fun to say like, oh, this is the best ride I ever had.
Then, a few minutes later, at a height of 8.5 kilometers, the drogue chute finally deploys the 1,000 square meter canopy of the main parachute. This slows the capsule down to a speed of 22 kilometers per hour. The capsule is suspended under the parachute with a specific angle relative to the ground. This angle helps the capsule to dissipate the heat accumulated on its surface and structure during the re-entry.
But then everything calms down, of course, once that the main parachute has deployed. You really can't, to the calm air, after this whole violent re-entry, the violent opening of the parachute, then you're hanging safely, slowly descending to the earth underneath your parachute. And this is actually the first time that you know, yes, I'm safe, we're gonna make it.
At an altitude of roughly 5.5 kilometers, the frontal heat shield and external window glass are jettisoned. The capsule vents excess fuel and oxygen from pressurized tanks to reduce any chance of an explosion when it hits the ground. In order to position the spacecraft adequately for the landing, the main canopy switches to symmetric suspension. This setup ensures that cosmonauts' seats are now perfectly positioned to absorb the landing impact shock. The retro rockets that were hidden behind the heat shield are prepared for firing. Inside the capsule, the crew seats automatically raise in order to prepare shock absorbers. Usually, the search and rescue team equipped with aircraft and helicopters start tracking the Soyuz capsule even before the very first parachute is deployed. The helicopters land next to the capsule shortly after touchdown, and the team help the crew to exit. Finally, 70 centimeters above the ground, the 6 retro rockets fire to further reduce the capsule speed to approximately 5 kilometers per hour. The capsule hits the ground, but the crew's seats continue moving down, and shock absorbers help to make the landing softer for the crew.
The soft landing is not really soft. You prepare for it by putting your arms against your body, not touching any of the metallic parts, all your books against you. You're not talking, not to put the tongue in the middle of your teeth, and you're laying there trying to be as inside your seat as well as you can. And you're waiting for this soft landing to happen, which for me felt like a head-on collision between a truck and a small car, and of course I was in the small car. So when this happened, it was like bada boom, everything shook. I was kind of checking in there, everything was saying, and then silence, everything was stopped. So I looked a little bit around, I looked at my crew members, and then I said, hey guys, welcome back to Earth.
Once landed, one of the first actions of the crew commander is to release one of the 2 ropes that connect the capsule to the parachute. This is important as, in windy conditions, it prevents the capsule from being dragged away on the ground by the inflated parachute.
You know that you're on the ground, you hear the voices of the rescue troops that are next to you, and you know that 5 minutes later they will open up the hatch and you can breathe fresh air.
The crew is now safely back on Earth. They will soon be reunited with their families and begin the rehabilitation process after their extraordinary journey.